So what I'm doing right now is I'm setting up Transient Tracker to work on my new Linux box. I've created a what is this called? Just a run configuration for ImageJ, which is the base tool that we're building Transient Tracker off of. And as you can see, if I hit run over here, that should load ImageJ, and I hope it loads it on this screen and not on the other. Please ignore all these weird depreciated warnings. This software was written a long time ago, and it's just telling us that a lot of the, of course it's on the other window, a lot of that code is depreciated from Java 6 up to Java 9 where we're at now. I think I have 8 installed on this box, but this is ImageJ. It's just an image manipulation tool that we use to look at star fields. And this is very boring because it's very dark. If I can figure out quickly how to increase the brightness, we should be able to get a better look at this star field. Enhance contrast, perhaps. Normalize, equalize, histogram. Equals. Oh, there we go. That's the one I wanted to see. Now that looks like a star field. Am I right? So this was the image that I started building this algorithm on. And then I'll kind of let you briefly run you through. We'll get rid of ImageJ for now. We're going to set up a new configuration to run my Transient Tracker tool. It is an application. We'll call it Find Objects. Oops, not BJECTS. We'll set our main class here. I got to drill down into the project to find it. I think it's called Object Finder. Nope, Find Objects. I had it right in the first place. And then we'll apply that. Set it, and then we'll run it. Okay, ignore anything. I don't know. I don't have any porn on this box anyway, so you shouldn't have to ignore anything. Transient Tracker. No, we need our desktop, which is where our images are. Fits. No, wrong file. Let's try that again. The algorithm doesn't work on PostScript files. It only works on fits images so far. So we'll try that again. And this is our... Okay, so what this does is it brings up a dialog box that asks you the number of standard deviations from the background that you want to choose objects in the image, and we just use 6. And then you'll notice it spit out a bunch of goods down here. This is a little more information than we probably need for today, but it also... Ooh, shoot, I think I commented out where it spits out the output. Let me, while I was troubleshooting and debugging. Yes, Peter, that is what the net is for. That and citizen science. But so far this box only has citizen science on it. I haven't... generally when I'm on the Linux side, I'm all about work, no play. If I want to play games and look at porn, that's what Windows is for. Then again, I'm getting too old to even appreciate porn anymore. But anyway, Pamela probably wouldn't appreciate me talking about porn so much while I'm repping her set this morning. So moving on. I got to find this output file that's created, and I've forgotten where. So skv.txt is something that I imported from IRAF. This is all the IRAF header information up here. And then these are the actual objects. But that's not what I'm looking for right this second. I'm looking for my output. Let me see. Let me get down here and make sure I didn't comment that block out. Oh, this isn't the right file anyway. I need find objects. Yeah, here, I commented it out. That's why it didn't work. So let's uncomment this, save, and then we'll run that one more time on that image. And then it should create an output file for me with less data. More useful, less troubleshooting, debugging sort of stuffs. So fits images. And of course this all keeps opening on my other monitor so you can't see it, because I think that computers are assholes. You know, I'd never talk about another human that way. Well, I would, but not like just out here in the open. But computers are assholes. All right, I'm going to catch up on chat for a second here. Windows. Yeah, I'll make fun of Windows. You're going to hear that a lot on my streams. I don't think she's shouting at the screen keeper. I think she's enjoying a book under a blanket with Eddie covering up her feet. I don't think she's feeling so hot today. Yeah, well, Mama's definitely away. The boss lady's away, and Jay will play. You know what I'm saying? Okay, so this should have spit out an output file, and there it is. Image objects. So as you can see here, this is very basic data. It has an X coordinate, a Y coordinate, and a center intensity. And then my DS9 output, I believe it was on the same image. Where'd it go? Where'd it go? Where'd it go? Here it is. Yeah, well, it's named SKV, so I should hope that... Okay, so I don't remember if SKV is the text that DF9... Yeah, it's definitely the text that DS9 puts out, because I have a tool here called DAOPHOT Parser, which parses all this information from here up, out, because all I'm wanting to do is compare it to this information, right? I'm wanting to make sure that it's finding objects in the same place that my software is finding objects. Now, there's several challenges with it. The first challenge I found was that DAOPHOT and PHOT, I think it's pronounced for photo, DAOPHOT. It uses bottom left corner for the origin, and my algorithm uses top left corner is the origin. So what I have to do is I have to take the Y data from theirs, because that's 39 from the bottom, not 39 from the top. So what I have to do is I have to subtract the image height from that to get it to match my Y data. Another thing you're going to notice is DAOPHOT has pixel 267.144. Now, I ask you, how TF do you get 1.144 of a pixel out of this thing? And that is very complex code that's in that program. So the next challenge is to round those, obviously, to the nearest pixel to match mine. And then, of course, Pamela turned me on to a tool called TV Mark in DS9 that also is supposed to mark images. But then I got lost after that, because it does mark them, but it marks them at partial pixels as well, and I have no idea how to compare that to the output of my algorithm. So, centroiding. Yeah, I will buy that. I think it's probably figuring out where each edge is, and then finding the center point of that plane. Unfortunately, that's my algorithm isn't quite that advanced, at least yet. Maybe we'll implement that. Maybe what I've got is good enough, but we're just kind of implementing functionality as we go, and then we'll make changes as necessary. I've still got lots of refactoring to do on this beast. It's still not exactly finding the same amount. For example, here I'll try to show you what I'm talking about here. Okay, so with that in mind, let's get rid of this, and let's try to figure out how to get DS9 to work on this box instead of the Mac. So I know I have to start by loading an XG term, and then from the XG term I will load DS9. No, I did that wrong. I did that wrong. Okay, I have to first load IRAF. No, I also did that wrong. How do we... I forget how to exit IRAF. Is it buy? Are you serious? Let's see. Yeah, okay. I gotta figure out what I'm doing here. Log out. Okay. Hey. Okay, so I need DS9 first. Then I need to get into the correct directory, not in the Transient Tracker project, but in the... Huh? Okay. Okay, now I can change into the SKV directory, which is where my image is that I need to mark, right? CosmoQuest, do you use IRAF on a regular basis? We can get rid of my image or my JetBrains toolbox as well. Let's get... Alright, okay, so I have something I need over here on my other monitor. So I know without looking it up I need to load DAOPHOT and then DAOPHOT, and then this is where it gets fuzzy and I got to use my beginner's guide. Ooh, I got to make sure the image type is correct. Cos used it back in the day, huh? All right. Well, I've been using it for about 10 days, so our knowledge may be crossing some curve together, but we'll figure this out together. I think what we're gonna do is show image type. Whoops. IM type, not IMG. Fits and why didn't set node equals, and then I have to figure out what my machine's called. Oh, come on, where are you at? System tools, perhaps. Why didn't that load anything? Oh. Is that... Keeper of Maps, you're confusing me. I was thinking that was a command to tell me my host in Linux that I didn't know about. Let's see here. Ah, there it is. Good one. Okay. Okay, here's where we can make sure that my image will fit in DS9. That will not work, so we had to set equal to IMT 2048. Let's see. Okay, so we're going to do a display. Thank goodness autocomplete works. And here we are. This is good. This is all working as planned. Keeper Maps like, hey, Brett, it's right there after your login name in the prompt, too. Okay, thanks. We'll learn Linux together as well. Okay, so this we're going to zoom out on a little bit so we can get the whole image in the screen, preferably. There we go. That's about as close as we're going to get. And then we can make this take up a little less room, too. Okay, and then now I'm going to see if I can figure out how to get it to run TV Mark on this bad boy. And that's quite a bit further down in this. Okay, image and graphics cursor input. This gave me trouble at the office this week, so it's possibly going to give me trouble here. I'm going to take a note of section 5.11 is where I changed the standard image cursor around. It's a great question, Keeper Maps. I got this image from some website that Pamela encouraged me to get it from, so I don't have the answer to that question. And I don't think the Fitz header has much data either. If I remember right, it's just got the length and width of the image, and that's it. No, timing test image, typical analysis sequence. Paranoia, I don't know what that means, so you'll have to give me more words. Let's see. Okay, effective exposure time, air mass. See, I don't have any of this information on this image, so none of this. Batch header editing, no batch, nothing. Man, this is way down here. I don't remember this being this far down. Oh, wrong window. I don't have a package called EXIF, so. Yes, lighting a cigarette with your mouse probably isn't going to go well. Okay. Uh-oh, we're getting close. I found DAOPHOT. Okay, so we'll run that on this image, and I'm going to try to get it close. I got so much going on here. I'm about to, like, my left eye is about to start twitching. I don't know where to go here. Okay, no, that's not it. Did I close JetBrains altogether? There we go. Okay, so if you'll notice here, my algorithm found 344 objects in that field, right? And this is all the X and Y, and then the sigmas on each axis value that were calculated. But 344 is what we need to know for now. What I'll do is I'll do a find skv, and we'll do a default. Okay, I think I left this at 2.5. We're going to set standard deviation background at 4. I think that was also... Okay, so you'll see here DS9 or whatever I'm DAOPHOT, I guess, found 309 images. Let's look again at how many this SKV file said. Let's go down the bottom and see if this is the same. So 317 that's found on this run, and 309. So obviously as I change those parameters, it finds more or less stars, right? So 309 is close. Let's run it again, see if we can get it closer. Ooh, only 215. That went in the wrong direction. 286, getting closer. 6, 4. $90. That is, we are definitely going in the wrong direction here. Huh. Way too... Anyway, let's see. Let's just leave... $309, that's close enough, right? We should be able to match a few of those objects with a few of my objects at this point. As far as the TV mark is concerned, CosmoQuest, that's a great idea. Actually, there is a test image that comes with the installation of IRAF that I think has 10 stars in it. If you look at the little guide that I'm using to work my way around this piece of software, you'll notice there's an image with 9 pieces of data called test, but so I might switch to that, but unfortunately today we don't quite have time. What's up, Uncle Bill? Uncle Bill made the room. Apologize in advance. We got some weird technical things going on. I'm hearing my own voice back in my head, and it's stressing me out. Let's see here. Okay, so this was... Okay, TV mark. Found it. Whoa. Well, then I got no sound, Keeper of Maps. Let's see. Okay, let's see here. I don't even know if this column and point that appears to have done nothing. Okay. Let's try this real quick. Oh, I think I forgot to turn it on to interactive mode. Okay. So this has been my life the last 2 weeks or so, is dealing with things like this. Trying to figure out why. Trying to figure out why this isn't... Whoops, wrong window. I see, this has been creating... Okay, so... Still didn't work. What? Well, maybe. Yeah, okay, never mind. Here they are. It did work. You can see in that upper right-hand corner all the little red dots that it's placing in the center of the objects, and in this big beast right here it placed nothing, and I'm sure that had something to do with the settings that I used as far as the thresholds for determining what's objects and what's not, because these tiny little guys got nothing either. These medium-sized bros, the cool thing is we can actually just do this by hand. Let's just pick something. Well, let's see, this thing got 3 centers. Do you see that? There are 3 pixels there that are red. Or at least, or it's marking it as 3 separate objects, one or the other. And then there's one. But we can look at the output from my algorithm and compare it to this. Just flopping the Y, we would have to subtract the image height, which is 2400. Let's just use this guy here. I don't know if I can get my mouse to land on it. It's so touchy and finicky. That's gonna be IRAF. I'm taking notes here. Yeah, I believe you're right, Cosmic. That's what these .fits.cu files are over here in the window. Let's see if I can show editor. Yeah, we know that's not going to work. Set editor equals Emacs edit skv .fits.coo.10. Are you shitting me? Sudo apt. I'll show you. Oh, sneaky. Anyway, now that Emacs is installed, so yeah, it's just like you say, Cosmic. It's just an output that that is placing red dots at each one of those XY coordinates. Yeah, I learned to use Emacs in my CS314 class. We had as an operating system class where we did a lot of programming in C, not C++, C. And we did a lot of tracing system calls through operating systems and stuff like that. And that professor used Emacs throughout the entire course, so that's just what I learned to use. Trust me, I try to use Atom. I try not to do command line text editors because they're ugly, and I like colors and smooth fonts and that sort of thing. But anyway, let's just make sure. Let's pick a couple of these and see if we can find them in my output. We can get rid of these. I'm gonna. Let's just. That's got two of them. That's weird. Let's use this guy. So this guy right here is 337X, and it's going to be Y will be 2400 minus 2005. That's going to be 395. So let's see if my algorithm found an object. We don't call them stars. We don't call them galaxies or asteroids or whatever. We don't call them anything because we don't know what they are yet, right? We don't have the math to figure out whether they're stars or galaxies or near-Earth objects or whatever. But there's my tool, and we're looking for something that... Now, my algorithm sorts by the Y, and that's here. So we're going to have to search for 395 here. Did I do something wrong? I don't have one at 395. X337, Y395. Okay, I got an idea. Let's load it up in ImageJ, because ImageJ will help us find a coordinate on that image as well. My system's starting to choke on me a little bit. It's like, bro, you got 983 windows open, and you expect me to load ImageJ? You crazy. Not to mention IRAF and DAOPHOT and IntelliJ and OBS and Chrome with 19 tabs. Is it loading? What is going on? Sometimes it will load the little image on me and I can't find it, but I don't see it. I wonder if... I don't think that worked. ImageJ. It says process finished, exit with code 0, so let's try again. And it's saying the same thing. Why is it not loading ImageJ? Or is ImageJ already loaded and I just... There it is right there. Son of a biscuit. It was already loaded. Tripping. Okay, so let's open that image. Desktop fits. That's the image. Bring that over here. Let's make it brighter. Enhance contrast. Okay, so we can see what's going on. Now we're looking for something at 3. Okay, so you see in this area right here, when I hover over the image, you'll see coordinates and intensities, right? So 337 is going to be in this range. And I think I need DS9 back. I have no idea which one of these it is. It's not that. There it is. Was that the image we chose? Or the star? 337, yes. Wait, now it says Y2001. Is this a different one? Because I wrote 2005. Not that it makes wild. 337, 2001. So that should be 399. So 337,399 it should be in my image. This definitely appears to be the same image. Am I correct? So this star right here, right, should be this star here. Somebody confirm that with me. This star should be the same as this star. That's not the star I had chosen though. This is. So this star should be the same as this star. See, this one's only going down to... Oh, you know what? I did this when I was writing the code too. I used 2400 instead of 2048. Oh, dummy head. Dummy head. So it's 2048 minus 2001. Because the image is 2048 by 2048, not 2400 by 2400. So that should be 337.47. It's funny, it lands on different pixels each time. But anyway, so that's this guy, which is 336.47 or 45, right? So obviously, let's zoom in a little bit. Control Shift plus. Why won't you zoom? Plus. Okay, so this is our star, right? Let's see if we can zoom also in this frame. That's not what I meant to do. What's going on here? Okay, so well, I can't figure out how to zoom in that. But anyway, these two stars right here are the same as these two stars right here. And as I had mentioned, somewhere around 337.47 is the center of this object as far as my algorithm is concerned. Okay, so it's finding most of the objects. My algorithm simply uses a standard deviation from the background, which is, I believe, an average of all pixels across the image, if I remember correctly. I just have to figure out what parameters to feed DF9 or DS9 to get it to find the exact same parameters mine found. But preliminary information is I'm finding the objects in the images. So it's kind of where I'm at. Pamela wants me to use that TV mark. I think she had mentioned something about some image coloring, which is what confused me because these are 32-bit grayscale images. But that's essentially... I don't think so, Keeper Maps, because essentially what my algorithm does, it does what's called an image walk, okay? So it starts at the top left corner, or the origin of the image according to this algorithm. I could probably change it relatively easy to make it match DS9. But my fear is that I'd get started on that and it'd be this big nightmare 3-week long situation. So it's easier just to flop the y-axis, right? But what it does is it scans top left corner and it scans straight across and it go the entire row until it finds one pixel that is 6 standard deviations over that background figure. Which, by the way, let me run my find objects algorithm again, and I'll show you something that I've got it. Another debugging piece of information that won't show on the final project, but just shows while I code it to make sure that sanity checks is what we call them in the office. But you'll see the n sigma, or 6, we chose 6 for n, right? So 6 sigma for this image is 13.612749, meaning any pixel that's over that intensity will be captured as part of some sort of object. And then what happens when it finds that image, it will run through this walk image method right here. And then it passes the image, the I and J, which again I should probably convert those to X and Y, but they're just iterators and loops. But I could easily name them what they are. That's the X and Y axes, that background information, the n sigma, which is 6 times that background, and then it passes a list of objects that it's already found, and that's for reasons that we'll discuss later. Oh, well, I need the method, not the calls of. Okay, so here is my walk image method. And basically what it does is it takes that first pixel and it sets candidate X as the X center, candidate Y as the Y center, which your candidate X is the I, canvas, I, and the X. Canvas is a 2-dimensional array. Or as you can see here, it's a 2-dimensional float array. But it sets that, whatever that X coordinate is the center and the Y coordinate is the other center. And then it sets the intensity to the intensity of that specific pixel. And then it begins walking, and what it does is it scans all 8 pixels around it. It uses edge detection, so it can tell if it's on an edge. It will not scan in the direction of the edge to avoid the invalid index on the array. And then as it finds, it looks for 2 things. It looks for any pixel brighter than that n sigma, or the 6 sigma. And it also checks that to see if it's brighter than the currently candidate center is what it is. So if it's brighter, it resets the center to the brighter pixels. But it includes all the pixels into an object called a UO, or an unidentified object. And then it just does that over and over. And in the process, it will set any pixel it detects to that background. And you'll see that here. If it changes anything, it'd be like, to avoid catching that pixel again, it sets that pixel to the background color, right? And then it just, all these else ifs are just, okay, so if it's the bottom left corner, it only looks, okay, so here it'll check up, right, and that's it. If it's in a bottom left corner. So bottom left corner has no down and no left, right? So it's only up, right, and right, if that makes sense. But it runs through all that, and then it just collects these pixels into objects called unidentified objects, and it keeps track of the brightest of those pixels and tags that as the center of the object. Yes, for the most part, that has always been the case. When I compare my output, and I'll tell you what I'm going to do just for the remainder. I'm already over my hour, but I'm going to hang with you guys for a few more minutes just to answer some questions about the algorithm. But I am going to get rid of DS9 now because it makes me feel creepy and awkward. But what I'm going to do is keep ImageJ up here. and my image, and then I'm going to bring, let me close some things to get them off the bottom so I can more rapidly get to where I need to be. That's just an unzoomed image there. Okay. Okay, I need that, and I think I'll keep Slack up. OBS I need. The JetBrains toolbox I can get rid of. My music, my jams, and then okay, so let's look at my output for this image, okay? And let's start at the very beginning, and we'll start at the top left corner, and I'll show you what I'm talking about. So this is the first image my algorithm finds, right? Deep Space Nine. I get it. I get it. Although I'm more Star Wars than Star Trek, I still get the references because I loved it as a kid. Did you all ever get my music out there, by the way? I can't remember what the final result was. Okay, so we need to zoom out. Alright, so we're in the top left corner. We should be finding... So the first image it finds is the X1241Y13. Wait a minute. Let's make this much larger because I'm tired of playing. Alright, so the first object is X1241. Y13. Something seems amiss here. That's on the right hand end of the object. Wrong window. So 1295 is in right here. So let's zoom in on this. Oh, 12. This is confusing. Find objects on this image. 6 standard deviations, please. Wait, did I ever Okay, yeah, this is the little section that writes it out to a file here. So 1241x13y. Okay. So this is the first object that it finds in the image. And let's zoom way in on that. So 1241.13, or if we look at the output, image objects output, 1241.13, and we need to keep this visible. So 1241.13, I just landed on that pixel. Zoom in further so I can. Okay, so I landed on that pixel. This is the first object it finds, and you'll see that center intensity in up here is 51.4375. And we see here that that is the center intensity of this object. And then the next one is 1295.28. So it's going to be over to the right some. It's probably this guy here. Okay, so 1295.28 with a center intensity at 23.125, and you can see in this area that that's the same thing. And DS9, it's not returning center intensities to me. My algorithm doesn't use anything like what are the words I'm looking for? Most, like, DS9 asked a bunch of questions about like air diffusion and the angle of, what's the word I'm looking for? Like how many pixels equates to like an arc second in the sky or something. It's very difficult to explain without being an astrophysicist, but my algorithm depends on none of that. My algorithm simply looks for pixels that have an intensity higher than the background of the image. Now, obviously, if we're going to do photometry or astrometry on these images, that's going to have to change. We're going to need that information to be able to sort out all the washout and the any other factors that may jump in on this deal. But that's essentially where the algorithm is now, and I'm obviously trying to not mimic, but at least get very close to DS9's output. And that's kind of where we're at today. So I will continue to try to get more comfortable with DS9 because it's apparent I'm going to be using this tool for many, many moons to come, because it's essentially what we're trying to emulate under the Apache 2.0 license, which is what NASA requires. So I'm coming to the end of my hour, and if you have questions, I'm happy to answer them. But otherwise, I have a little girl out there that's hanging out with me this weekend I probably need to go hang out with. So who's got questions for me? I will take the recommendations to heart as far as getting more comfortable with DS9 and that sort of thing. I actually need to do the same thing with ImageJ. I probably should be more fluent with zooming around in images instead of that little cluster stumble that I just did trying to get around in there to point out what my algorithm's pulling out of there. But this is a work in progress, and with trips to Washington D.C. and having to learn new software and looking at old, like that walk image that walk image method that I just kind of ran you through briefly, I essentially stole that from MStar. If you know IRAF, you probably know MStar, and MStar is ancient C code, like super ancient. It was very hard to read and kind of extract what they were doing to the image, but that's where my walk image, the inspiration for it, that's where it came from. Because essentially I could see that he was finding a pixel that was a candidate object and then just scanning around it, and then recursively, after you scan those 8 images, assuming you're in the center of the image, after you scan those 8, what you do is you pick the brightest of those 8, you move there, and then you recursively walk again. And of course the ones you just left have been changed to the background image so you don't recapture those. And then it just kind of follows it to the brightest pixel. And then I know what you're thinking. You're thinking, well, what if it just goes straight to the center? It doesn't, you catch the upper left and go straight to the center. It doesn't catch upper right, lower left, anything. Well, I've also allowed for that in, I believe it is this block of code right here called get objects. Okay, and so what it does is it creates an array of unidentified objects, array list of unidentified objects called UOList. And then let's see here. Here it sets the index to -1, and if the list, I think this is actually a superfluous piece of code. It breaks everything when I take it out, so maybe not. What it does is it looks to see if it's empty. If it's empty, it just pokes it in there. There's no object for it to be a part of, right? If it's not empty, what it does is it scans through and it looks for, there's another method here, find nearby objects. And what that does, I think that's next here, is what that does is it scans every object in that list to see if that X and Y coordinate is within. Here it's set to within 2 pixels, but I'm going to change it back to within 1. And then what I'm going to do after it finally finds all the objects, I'm going to do one final run through the objects to see if anything belongs to another object. And it's going to be a little more complex than just having 1 pixel edge in common. It's going to probably have to have more than 1 pixel edge in common, because it's easy to see in these images that sometimes 2 stars touch, and I'll have to find some sort of like round edge detection. If the round edge is going away from each other, then they're not the same object. If they kind of meet and meld, then it is the same object. But that's essentially what I have in mind to handle all that. But then again, we're going to have to get all this other data in here, aperture length and air mass and blah blah blah, all these things. Yeah, a peak finder essentially is what it is, but it also kind of smashes things together that it thinks belong together. And I've ran through and hand checked all this data, and of these 344 objects, all but like 5 or 6 of them are individual objects. Like there's 5 or 6 of them that it didn't quite figure out to put together as one object. But, Pamela said, hey, that's real close. Let's move on. Let's get some functionality. We'll go back later and figure out how to, kind of break the images apart. Speaking of exciting news, I know that most of us probably saw that we are starting to find Kuiper Belt objects, which is cool because those don't emit light, right? They just reflect it. So, and they're small. But I think Messenger was the telescope that found them. With that information, yeah, I'm looking forward to getting the scopes out here in 4 years and tracking that through the sky when it comes back towards us. I heard February 2022 is when it was supposed to be heading back. But anyway, like I say, if there's no further questions, I think I'm going to call it. And we appreciate you coming in and hanging out. It was a blast as always. You guys are keeping me humble and helping me learn, and I appreciate you. We appreciate your contributions to the Patreon and the Amazon wish list. I don't have access to the Nightbot, so I can't use any of those cool bang commands. But you guys have already been taking pretty good care of us, so I don't feel like that's necessary. And anyone that wants to take more care of us, I'm sure can check that out on the CosmoQuest blog page. Brief overview of what I'm working on. Yeah, essentially, like as far as the project, well, the Project Transient Tracker is a tool that we got a NASA grant on to write a piece of software. It's technically written to detect NEOs, or near-Earth objects. Again, those Kuiper Belt objects, or hopefully what we're going to start. I want to start throwing messenger data into this algorithm and start finding these objects that don't match solar system objects, right? So if we find an object and it's not one of the planets, or it's not Vespa, it's not one of these, it's not Pluto, or what do they call him, Pluto now? I don't even know what they're calling it now, but it's not those things, then we know we found either a Kuiper Belt object or an asteroid or a comet or whatever. That's essentially what the grant was written up to find. Obviously, we want to be able to use this throughout the sky, though. We want to be able to, dwarf planet, that's the word I was looking for. We want to be able to use this throughout the sky. We want to see things moving through other star fields that don't belong. Pretty soon, I think Corey, our lead developer, will be joining me in doing trigonometry on these images and then placing them in the sky map. You know, there's a big sky map that the astronomical community has put together. And then we're going to start, and just like CosmoQuest and the mapping tools for Earth, Moon, Mars, and Vespa, we want to build a mapping tool for the sky, right? So that's essentially the program. And Transient Tracker is the software that I've been writing for the last few months to hopefully get that done. Plate solving. Not sure what that means. Keeper of Maps. Thanks for hanging out, Guido. I appreciate you. Glad I could get one in during the day when you aren't trying to go to sleep. That's always cool. And I don't have a stream plan for this week, again, because it's been a crazy busy week with me trying to get this DS9 data to match my data. And Pamela and I still haven't had an opportunity to talk about when I could do that regularly. And she's the boss. She's the master of where my time gets spent. So I obviously need her okay to get that knocked out, because I don't think she wants me to do that for free. She wants me to do that to get paid, because I think she finds it a valuable tool to bring in folks into the citizen science. We want folks to be able to use this tool once it's done. And I think there's a jar file up on the public. Hold on, I'll paste the public GitHub into chat, and then we will... I think there's a jar file up there you can download and run, and it will ask you to pick a FITS image. It will ask you to pick an N-Sigma, and then it will spit out a text file called imageobjects.txt that has the XY coordinates and the intensity of the center of the object. Let me get to GitHub and get that link for you. I think next time I stream on CosmoQuest, I'm going to try to get access to the Streamlabs site and get control of Nightbot as well. But for now, I think this is it. Yes, here we go. Control-C, Control-V. That's where you can go take a look at the code. And I believe there is a jar file there. If not, and you're comfortable compiling Java software, you could definitely create your own, because it is functional. It has the same functionality as the one that I'm using, which is on the non-private repo. I have made no advancements other than writing this class, this DAOPHOT parser, which pulls data out of, or pulls the text out of the DS9 output or the DAOPHOT output, flops that y-axis so it should match mine, and then it's not even done because it's not even writing it out to another file, and then it will pull in both files and run essentially a diff on them to see where they differ. And that's what I've been working on the last 3 or 4 days or so. So anyway, I'm going to call it, go hang out with my little girl. Thanks for hanging out with me. We appreciate you. We appreciate your support. We appreciate you helping us out with the website and on the forums. We couldn't do it without you guys. But anyway, calling it a day. Thanks for hanging.